Bismillahirrahmanirrahim. Electrostatic generator, and in electrostatic generator we will study the von de Graff generator, which is an electrostatic generator. Okay, so von de Graff was a scientist, and it invented this generator. So that's why the generator has been named on his name. Okay, so the von de Graff generator is an electrostatic generator which uses a moving belt. Okay, so a moving belt to accumulate electric charges on a hollow metal globe on the top of an insulated column, creating very high electric potential. Okay, so I will show you a sketch of Van de Graaff generator. In this you will study that there will be a moving belt made up of rubber, and the charges would be accumulated, will be moved through this moving belt, and will be accumulated on the upper hollow globe made up of metal. So, and there will be an insulated column between the metal globe and the 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 rubber belt. Okay, so how it will perform? So first of all, have a look on the components of the Van de Graaff generator. A simple Van de Graaff generator consists of a belt of rubber or a similar flexible dielectric material. Okay, so the belt must be made up of a dielectric material, not the conductor. Okay, moving over two rollers of different materials. Okay, the belt will be moved around two pulleys. Okay, so one will be connected with the motor, so that it will give a power to the belt to rotate, and one of which is surrounded by a hollow metal sphere. Okay, so two electrodes in the form of comb shaped rows of sharp metal points are positioned near the bottom of the lower roller and inside the sphere or the roller. There will be two rollers, the lower roller and the upper roller. Okay, and there will be two combs. Comb 1 is connected to the sphere and comb 2 will be connected to the ground. Okay, so before the working, let's have a look on the sketch I have described to you people. Okay, so this is the external view of the Van de Graaff generator. Okay, so in this figure you cannot see the revolving belts and the roller, so but I will show it in this next sketch. But first have a look on the an external structure of the Van de Graaff generator. Okay, so this is a metal globe which is hollow from inside. Okay, and that will be used to accumulate the electrostatic charges. Okay, this is the insulated column, and this is the ground. Okay, the negative charges will be accumulated over here, and the positive charges will be accumulated on the hollow metal globe. Okay, and the spherical device. Okay, if you, for the demonstration purpose, if you want to discharge these charges, so the negative will be accumulated over here because it is connected to the ground. So when we get close this spherical device to the hollow metal globe, so the air in between these two globes uh, will be breakdown, because if the charge is so high that it can exceeds the breakdown strength of the air inside these two globe, so a discharge will be seen in between these two globe. Okay, so this is just for the purpose of demonstration. Okay, so okay, now this is the internal structure of that Van de Graaff generator. Okay, so this is a roller belt, okay, revolving or moving through these two rollers. Okay, this is the upper roller, this is the lower roller. Okay, and two combs, okay, which I was talking about. These are the comb. Okay, comb number one, two. One is the one is connected over here. Okay, the, to the belt. Okay, and the second with the ground. Okay, so the charge will be accumulated on either faces of this belt. Okay, the positive will be appeared over the outer face, and the negative will be appeared over the inner face. Okay, so the as the roller rotates, okay, so the negative will be mm, accommodated on this roller, or this through this comb it will be accommodated over here, and the positive from this roller will be moved transferred to this globe, a hollow globe, through this comb. Okay, so this will provide a path for the positive charges to transfer over here. Okay, so by this way the charge will be accumulated over here. So this is the role of the combs and the roller. Okay, roller moves, the friction generate the electric charges. Okay, so the blue dots represents the positive charges, and these reds represents the negative charges. Okay, so attracts the negative charges, and belt of the rubber transport the charges. Okay, actually if this belt stop, so no transfer will be occurred to this globe. Okay, so the belt is actually acts as a transparent path. Okay, so as it rotate, it also move the charges along with itself. Okay, so the accumulating into globe. Okay, now you can see positive are with the potential difference. When the potential difference is very high between these two globe, so it will produce a spark. Okay, because these accumulated charges have enough potential that mm, it can exceeds the breakdown strength of the air between these two globes, and ultimately it appears as a discharge between these globes. Okay, it is just like the charges on the cloud. Okay, the lightning through the cloud have the same phenomena, that the charges are accumulated over the cloud due to the friction, and when the positive charge cloud comes in the range or near to the negative charge cloud, so the air between these two has been the breakdown has been occurred between these two charged bodies, so a lightning will appear. Okay, this is actually the discharge of these accumulated charges on the cloud. Okay, so the charges on the cloud is also are also the electrostatic charges. Okay, so now come to the working. The method of charging is based on the triboelectric effect. This is actually a triboelectric effect, such that simple contact of dissimilar material causes the transfer of some electrons from one material to another material. Okay, so you can see that the transference of the charges is occurred in Van de Graaff. So this effect is called the triboelectric effect. Okay, in which the charges is transferred from one material to another material. Okay, the belt carries away negative charges on its inner surface. Okay, the belt, then the negative charges are appear on the inner side of the rubber, while the upper A roller accumulates a positive charges. Okay, as you can see from this figure, the positive charges are accumulated over here, the negative charges is moving on the inner surface of the belt. The strong electric field surrounding the positive upper roller induces a very high electric field near the point of the nearby comb. So at the points, the field becomes strong enough to ionize air molecules, and the electrons are attracted to the outside of the belt, while positive ions go through the comb. Okay. So according to the Gauss's law, the excess positive charge is accumulated on the outer surface of the outer shell, leaving no field inside the shell. Okay, according to the Gauss's law, the Q, the electric flux lines is equal to the Q enclosed in that closed body. Okay, so for the Gauss's law, closed body must be is must. Okay, Gauss's law is not applicable on the open body. Okay, just like a circle is also an open body. For this purpose we need sphere or cylinder. Okay, cylinder which is packed. Okay, and square is also valid. Okay, means 3D body which is in closed shape. Okay, so these were the figures which I have already explained to you, and the mechanism has been explained with different figures in sequence. Okay, this is the first sequence. This is the first sketch of the sequence, and now the second, the third, the fourth, the fifth, the sixth. Okay, different. So up till the discharge. Okay, this is another a very clear picture of the Van de Graaff generator. From this, you can also see two rulers. Okay, here and here, and the lower roller accumulates give the path for the negative charges to accumulate over here. Okay, you can see that this is a belt in which the positive charges are appear on the outer surface and the negative charges has been appeared in the inner surface. So the positive charges of the outer surface is moving upward because of the motion of this belt. Okay, these arrow show the movement of the belt. Okay, so when these charges go up, so this is a comb. Okay, represented by 2. So this comb actually give the path for these positive charges to accumulate on this metal hollow globe. Okay, so and the negative charges are moving or can be accumulated to through the ground. Okay, over here, and this zigzag uh, path shows the discharge between these two. Okay, means the air in between these two well has been breakdown. Okay, now this is a link for uh, you people to watch this video. Okay, uh, this is another a very informative video, so let's have a look this video which is very informative, and this is also related to the Van de Graaff discharge.
Van de Graaff generator is an electrostatic generator which is capable of producing enormously large static electric potential.
Okay, so Van de Graaff generator is an electrostatic generator which is capable of producing enormously large static electrostatic potential as high as 20 million volts. Okay, so this is very effective generator for generating the electrostatic charges. Okay, it is designed by the American physician Robert J. Van de Graaf, so that is why it is named as this. Okay, now you can see that the charges are this is the upper roller. Okay, and through the upper roller where this comb, the charges is accumulated on the outer metal globe. Okay, so this is the mechanism of the roller, the belt. Okay, this is a belt which must be made up of some dielectric material. The two rollers, one is the upper and the lower. The lower is connected to the motor so that it get power mm, of the rotation. Okay, the metal globe, the comb. Okay, uh, which will be connected to this, so that the charges is transferred to it. Okay, and this is the upper comb. Okay, which give the path for the positive charges to move through the outer globe. Okay, so okay, the motor, this is the motor which give the power for the rotation. Okay, now it has been started with the charges. Okay, so due to the electrostatic effect, the negative charges will be appear on the inner surface of the belt. Okay, this is the inner surface. Okay, now this is the outer surface. Okay, the charge is accumulated, the positive charges is accumulated on the outer surface of the globe, and its amount and the quantity is increased. Okay, as the roller is moving, you can see the charges is the number of charges is going to increase, and if it is so high that cause the it can cause the breakdown of the air surrounding it. So it look, this was the discharge. Look, this was actually the demo of the discharge, which occurred around the air around the this globe has been breakdown. Okay, so this was all about the Van de Graaff generator. I hope you will understand it. Thank you.